Section 2.1, Part B, the distance formula. Today we're going to be learning how to find the distance between 2 points. So if you look here to the right, I have 2 points, x sub 1, y sub 1. That's this point right here. And I have another point right here. This is x sub 2, y sub 2. And I want to find the distance between there. Well, I could make a triangle, a right triangle, and I can use the Pythagorean theorem, which is a squared plus b squared equals c squared, and I can calculate and come up with a formula for the distance between these 2 points. So what I'm going to do is I'm going to skip all that algebra that goes between a squared plus b squared equals c squared and calculating all that, and I'll just give you the formula. But I wanted you to know where it came from. It just didn't drop from the sky. It came from a formula that was derived by 2 points, making a triangle, and doing the Pythagorean theorem. So let's practice using our distance formula. We have 2 points here, 3, -5, and -2, 8. And so I just kind of sketched them. 3, -5, I put a dot right here, and -2, 8, I put a dot right here. And I want to find the distance between there. And even if I had graph paper, it would be hard to count the squares between there because it's slanted. So I'd make a good guess, but not exact. But the distance formula would be exact. So this is the x's. I subtract the x's and square them. So 3 take away -2, that's right here, squared, plus, now subtract the y's, -5 minus 8 squared. Well, 3 minus -2 is 3 plus 2, which is 5. 5 squared is here. -5 minus 8 is -13, and I'll be squaring that. Well, that's equal to 25, because 5 squared is 25, and -13 squared is 169. So my answer is the square root of 194, which may not mean a lot to you unless you put it in a calculator, take the square root, and find out that it's pretty close to 14, not quite 14, but that gives you an idea of how far apart these 2 points are. Okay, so now I'm going to erase this, and I'm going to put a different problem up here that will also use the distance formula. And this problem is, I'm going to give you 3 points, and I want us together to be able to figure out if these 3 points make a right triangle. So the 3 points are 0, -2, 5, 1, and -4, 3. Okay, so let's get an idea of where those points are. 0, -2 is down here. 5, 1 is up here. -4, 3 is up here. So here we have a triangle. Not sure if it's a right triangle. Kind of looks like it, but you know, it's just a sketch. So I want to know, is this really a right triangle? Well, this point right here is 0, -2, and this one is 5, 1, and this one is -4, 3. Okay, so I need to find the distance between this one and this one, this point and this point, and this one and this one, because a squared plus b squared has to equal c squared if this is a right triangle. So let's find this distance right here between -4, 3 and 0, 2, -2. Okay, so the formula says subtract the x's and square them. Subtract the y's and square them, and we'll take the square root. All right, this is negative 4 squared, which is 16. And this is 3 plus 2 is 5 squared is 25. So that becomes square root of 41. So I know what this distance is now. It's the square root of 41. Okay, so next I want to find this distance between 0, negative 2, and 5, comma 1. So again, subtract the x's and square them, and subtract the y's and square it. Alright, so 0 minus 5 is negative 5, and I square that, and I get 25. And this is negative 3 squared is 9, so I get square root of 34. Okay, so this distance right here is square root of 34. But now I need to find this distance between negative 4 comma 3 and 5 comma 1. Again, the distance formula. Negative 4 minus 5 squared plus 3 minus 1 squared. This is negative 9 squared, which is 81. And this is 2 squared, which is 4. So I end up with the square root of 85. So if this truly is a right triangle, I should be able to do a squared plus b squared equals c squared. Okay, so let's try it. The square root of 41 squared plus the square root of 34 squared. If this is a right triangle, it should equal square root of 85 squared. Well, the square root and a square both cancel each other out, and we get 41 plus 34 equals 85. But 41 plus 34 is 75, not 85, so these are not equal. Therefore, this symbol is therefore the lines that connect 0, negative 2, 5, comma 1, and negative 4, comma 3 do not make a right triangle. Okay, so that is a way to prove, using nothing but the distance formula, we were able to prove that those 3 points, lines connecting them, do not make a right triangle. Okay, I'm going to erase the board. I love this big eraser. Okay, so now we're on to our last problem, and that is I want to show if these points are collinear, and we'll have to talk about that word. Collinear. Collinear means they all fall in a straight line. Well, I could kind of sketch it and make a guess. I could say, okay, negative 2, 5, 0, 3, 8, negative 5. Well, they might be. I can't really say for certain. But one thing I do know is if they are on the same line, if I find the distance from here to here, and then add it to the distance from here to here, that should be the same as if I found it from the beginning to the end. Now, if my points have to go this way, then they're not going to be equal to the length of the line going from here to here. So we're going to find out this distance and this distance, add them together, and we're going to see if it's the same as the distance from the initial point to the end point. All right, so let's find the distance from -2, 5 to 0, 3. All right, we subtract our x's and the y's, and I get -2 minus 0 is -2 squared is 4, and this is 2 squared, which is 4, so I get square root of 8. But I can reduce that. I can get the square root of 4 times 2 underneath there, which is the same as the square root of 4 times the square root of 2, which is 2 square root of 2. Next is 0, 3, 8, -5. I have 0 minus 8 squared plus 3 minus -5 squared. Alright, so this is -8 squared is 64, and 3 plus 5 is 8 squared is 64. So that gives me 128. But that can be written as 64 times 2, which is the square root of 64 times the square root of 2, which is 8 square root of 2. Okay, so we've got this distance right here as 2 square root of 2, and this distance right here, 8 square root of 2. So if I add those together, add these two together, I will find the distance from beginning to end. 2 square root of 2 plus 8 square root of 2. I get 10 square root of 2. So that should be my answer when I find the distance from here, from beginning to end, if these are collinear, if they're all in the same straight line. So I take my beginning point, -2, 5, 8, -5, and I find the distance. -2 minus 8 squared plus 5 minus -5 squared. Alright, so this is -10 squared is 100, and 5 plus 5 is 10 squared is 100. So I get the square root of 200, which is really the square root of 100 times 2, which is square root of 100 times the square root of 2. And the square root of 100 is 10 square root of 2. And that matches this, so yes, they are collinear. Okay, that's the end of this lesson, 2.1, Part B, on distance formula.